So we're going to look at creating exponential functions from our word problems. So far in this unit, through our mastery pathways, you've looked at how to distinguish between growth and decay. You've looked at, if you are given a function, how to interpret what the different pieces of the function are and what they mean. And today, in this video, you're going to take a look at actually creating exponential functions from word problems. So let's just remind ourselves of the general form of an exponential function, which we can take as f of x equals a times b to the x over n, where a is the starting value, b is our base, x is the time since the start, and n is whatever interval of time we are looking at. This was just the basic exponential function. And we also looked at percent growth and decay, where our base changes ever so slightly, but everything else remains the same. So something like 1 plus or minus r to the t over n, where we use addition for growth and subtraction for decay, and the r is the decimal of whatever percent growth or decay we have. So let's look at an example here. You open a new savings account for college with $500. The account has a 3.5% interest rate. Write a function that shows the account balance, b of t, after t years. So whenever you get a problem like this, you want to assume that the money you're putting into the savings account, the $500, you're not taking anything out and you are not putting anything additional in. So the only thing that is getting added in is your interest. So our for the type of equation we'll use, we see that we have a 3.5% interest rate, which means we're going to want to use the f of x equals a times 1 plus r to the t over n. When you get interest back in a savings account, that's always interest added in, so your account will be increasing over time. So our a, or our initial value, is going to be our $500. The r, which is the growth rate, is 3.5%, but we need to turn that into the decimal. So we divide it by 100 to get 0.035. T is the time in years. We're going to keep that as the t. And the n, our interval of time, since it doesn't tell us, we assume that it's every year. So we'll leave that as 1. So if we fill in our function here using b and t instead of the x and the f, we will get b of t equals 500 times 1 plus 0.035 to the t, or simplified, b of t equals 500 times 1.035 to the t power, where all we did there between this point and this point was add together that 1.035 to the t, and that is the final function we'd be able to use. Let's look at a second example. A city in Wisconsin currently has a population of 1.5 million people. The city's population is decreasing at a rate of 5% every 10 years. Write a function to show the population p of t after t years. So since I have a percent, I know I'm going to use my 1 plus or minus r. And since it's a decreasing population, I know I have a decay since it's getting smaller. And so I will use my 1 minus r to the x over n function. So my initial value, or my starting value, it's 1.5 million. So I know at the end that the number I get is representing millions, but I don't have to put 1, 500, 000. I can use what the equation or the problem used, which is just 1.5. I just need to know that that indicates millions. My decay rate, the r, is 5%, which when divided by 100 is 0.05. My time is just t in years, and my interval of time this time, every time, the amount of time it takes to decrease in population is 10 years, so my n is 10. P of t equals 1.5 times 1 minus 0.05 to the t over 10. And then if I simplify that 1 minus 0.05, I will end up with p of t equals 1.5 times 0.95 to the t over 10. That is my most simplified form of this function, and so that's what we would use then as the model for finding the population of this town in Wisconsin. Let's look at one more example. In this example, we're actually not going to be writing out a full equation. We'll just be writing an expression. Alpha-itis is spreading throughout CCPCS. It started with 2 people infected and triples every 5 days. Write an expression to show the number of people with alpha-itis after 7 days. So let's think about this. We're tripling. We're tripling every 3 days or every 5 days. So we're tripling every 5 days, and we started with 2 people. So this time, since I'm getting a straight triple, I'm going to use the function f of x equals a times b to the x over n. My a, the number of people that started with this infection, was 2. My b, the base, or how much it's increasing, it's tripling, so my growth factor is 3. My time is 7 days, so this is asking me to just write an expression to show the number of people with alpha-itis, which will be 7 days. And my interval of time, or how often this tripling happens, is every 5 days. So if we were just to write an expression or an equation without the 7 days part, we would get 2 times 3 to the t over 5. But we know that the t is 7, or the x here is 7. So my most simplified form, or the expression we would use to show the number of people with alpha-itis after 7 days, would be 2 times 3 to the 7 over 5.